Good morning, students. In today's lecture, I will be teaching the basics of coordinate geometry, which is chapter 7 of class 10th mathematics. So, let's start with coordinate geometry. In the previous class, in the your previous class, that is the ninth class, you have studied that what are what is graph, what is x coordinate, what is y coordinate of a point. So, in this, I will be just making you one step ahead of what you have studied. So let me draw the graph. Assuming this is my graph, this is x-axis, so this is x dash, this is y-axis, this is y dash, and center is given to the origin. Now suppose I have a line. Suppose I have 2 points. This is 1 point, another point, and the coordinates of this point are suppose x1, y1, and this is x2, y2. Now if I this is point, let's say this is point P, this is point Q. Now what I need to find is, if I need to find is this is line segment PQ length. So this line segment PQ length will be given by this. If I join this, I will be getting PQ line segment, and if I need to find the length of this line, that is this L is equal to how much, then how I will able to do this. So there is nothing new in this, you already know this how to do this. So first draw a perpendicular from this to this, this to this. Now so you know that this length is how much? This is x1 y1, which means this is y1. And what length is this? Is how much is this length is y2, because this point Q is x2 y2, so this length is y2. Now if I join this point, then this length is given to me. See, this is from here to here, this is x1 because it is for point P, and from here to here this is for x2, which is for Q. So this much length is given to be x2 minus x1. Length is x2 minus x1. And what is this length? If I say that I want to calculate this length, this length is y2 minus y1. y2 minus y1. Now you can see that this is a right triangle. Let us suppose this is R, right triangle. So in triangle PQR, angle R is 90 degree. So there is only one theorem you can apply, it is Pythagoras theorem. So using Pythagoras theorem, what you get is this PQ square is QR square plus PR square. What is PQ square? What is QR? QR I have, it is given that this is y2 minus y1. Length is y2 minus y1 square. Plus what is PR is, this is x2 minus x1. So this is x2 minus x1 whole square. Which implies that what is the length? This is square of this. So what is the length is? This is under root of x2 minus x1 square plus y2 minus y1 whole square. Y1 whole square, which is your formula. So if 2 points are given that whose coordinates are x1 y1 and another point coordinated x2 y2, then the distance between these 2 points is known as, is given by x2 minus x1 whole square plus y2 minus y1 whole square whole under root. So this is my first formula now. So this, in this way you can calculate the length of these 2 points. So now next is, how will you calculate if a point divides the particular line in some ratio, then how will you calculate what is the ratio of this? Let me draw again this. Again I am drawing the same figure, but this time I am doing, so this is your line segment and this is your point. Again I am drawing point P, this is point Q, and the coordinates are given to be x1, y1, and this is x2, y2. Now this time what you need to find is that you need to find the point, the coordinate of a point R, coordinate of a point, this is R. I write it as this is the coordinate is given to, suppose this is xy. What will be the xy such that this R divides PQ in the ratio m is to n. M is to n the ratio. What is the coordinate of R such that this R divides the PQ in ratio m is to n. Again, from here you cannot deduct, you cannot see anything, but if you draw this perpendicular, many things will get clear. This is also 90 degree, this is also 90 degree, this is also 90 degree. Now what is this? This is for P, x1, y1, so which means this length is y1. I am saying that this is x dash, this is origin, y dash, this is y1. What is this? This whole length is this for x2, which x2 is x2 of y2, this is y2. And what is this length? This is x1 xy, so this will be y, which implies that what will be this length is, this length will be y2 minus y. What is this length? This much length till here, this is y and this is y1, which implies this is y minus y1. Same thing I'm doing for this down direction. This whole length is not this whole length. From here to here, this length is y2, and this is given to be this much is given to be y, which implies that this length is y2 minus y, and this length, this much length is given to be your y1. This is for point P, which implies that this length from here to here given by y minus y1. Now you can see that in triangle, that is in triangle, let's suppose this is m, this is n, this point is n. So in triangle PRM and triangle RQN, so this angle and this angle is same because this is parallel line, this is cutting two parallel lines. So angle P equals angle R, angle M equals angle N, and since two of angles of a triangle are equal, the third will also be equal, which is the angle R equal angle Q, which implies that this triangle PRM is similar to triangle Q1 RQN. RQN. Since these two are similar, which implies it is PR by RQ. Nothing but, if you say this is the sides, so sides take it one by one, that is RM by QN equals PN by RN. What is PR by RQ? See, from here, that is, you can see that this PR is N and this is N. So this is N, this is N equals Rn. What is Rn? Rn is, you can say that this is y minus y1. Y minus y1. What is Qrn? What is Qn? Is y2 minus y. What is Pm? Pm is, you can see from here, is Pm is y minus y1. Sorry, this is x2. Sorry, this is x2. This is x. This is x2 minus x. This is x minus x1. x1. This is, what is Pm? Pm is x minus x1 by, what is Rn? And this length is x2 minus x. Now taking one relation at a time. One relation at a time, which implies that if I take this one relation, take this first relation, so this is like n by n equals y minus y1 by y2 minus y. Then if you go beyond this, this is multiply, cross multiply, this is m y2 minus y equal to y minus y1 into n. Neither ny2 minus ny equals to ny minus ny1. Now if I take m here, this y this side and n this side, which implies that n plus ny equals ny1 plus ny2, where y is nothing but ny1 plus ny2 by n plus n. And similarly, if you take the x relation, you take this x relation, it will give x equal to nx1 plus nx2 by n plus n. This thing you need to remember. I will remember. You can see from the diagram that this is for calculating r. This x value is, this is x1 near n. So x1 in not near. This is x1 near to n. So x will not be multiplied by n. It will multiply by the further one. So x1 into n plus x2 into n by n plus n. This is given, this is nx1, this is nx1 plus nx2, this is nx2 by n plus n. and same thing with y. And this here y is also far away, so y is multiplied with this, and this y2 y1 is multiplied n, and y2 is multiplied with n. So this way it becomes easy to remember this formula. So this formula is known as section formula. Section formula. Previous one was known as distance formula. Because why distance? Because this gives the distance between the 2 points. Distance formula. This section formula. Now there is a one condition, is that if from same thing only you can derive that is, if point this is p x1 y1 and and q x2 y2 is divided in the ratio k is to 1 by point, suppose r whose coordinate is x, y, then x is given to be, this is in order, that is divide pq, this is in order, then this is k is near to x1, which implies that x1 multiplied with 1. This is nothing but x1 into 1 plus x2 into k by 1 plus k, or you can even write it, this is x1 plus x2 k by k plus 1. And similarly y is also y1 into 1 plus y2 into k by 1 plus k, nothing but this is y1 plus y2 k by 1 plus k. It's a special case. One more thing is that if this divides it in the ratio 1 is to 1, in place of k, if you substitute the value 1, then what you will get is, that is x, y, and y is nothing but x1 plus x2 by 2, that is, it is bisecting it, and this is y1 plus y2 y2. If the points are divided in the ratio 1 is to 1, the line is divided in the ratio 1 is to 1 by the point r. So this is the condition. Now next is, this is how to calculate the midpoint. Now next is, what if you need to find the area? What if you need to find the area? Suppose there is, I'm again drawing this graph. Now I'm drawing bigger graph. Suppose this is x, this is x dash, y dash, y, this is origin. Suppose there are three areas always found by at least 3 points. So this I'm deriving for 3 points only. So if you let it be, this is PQR, and this is, suppose this is x1 y1, x2 y2, this is x3 y3. So directly you cannot see how to calculate this, so you need to draw this line. I substitute this in y. This much length is this is x1. What is this? This is given to be x3. What is this? This is x2. Similarly, if you this is y. So this is y. In terms of y, this is y2, y3, and this is y1. Similarly, this much length is x1. This much length is x2. This from origin is x3. Now let me make this. This is 90 degree. This is also 90 degree. This is also 90 degree. Let me name it as to be M N, or even write ABC, A, B, and C, A, B, and C. So you can see from the figure is that what is this much length. Now this length is y3. Again writing this is y3. Sorry, let me write with this different pen. Length is y3. No need to write this. Just I am doing the solution. Directly I am doing the solution. So here what is so if you calculate that is area of triangle PQR. What is area of PQR? Is given by, see, M equals, this is area of this plus area of this minus area of this much. So what it is, that it is equal to area of trapezium APQB plus area of trapezium BQRC minus, this is the most important thing, is minus area of trapezium APRC. Now what is the area of trapezium? Trapezium area is, what is the area of trapezium? Sum of parallel sides into height by 2. This is sum of parallel sides. So what is APQB? The parallel sides are AP and QB, and height is AB. So half into sum of parallel sides is AP plus QB into AB plus what is area of trapezium BQRC. So BQRC is sum of the parallel sides. Parallel sides are BQ and RC. So this is half BQ plus RC into height. What is height is BC into BC into BC plus sorry minus. Next is minus. What is next trapezium? Next trapezium is APRC. So what is APRC in parallel sides are AP and RC, half AP RC into what is into the height. Height is AC. And if you can see from figure that AC is nothing but AB plus AC is nothing but AB plus BC. Now if you substitute this value, what you get is this is half you can take common from all. This is AP plus this is sorry AP into AB plus QB into AB plus BQ into BC plus RC into BC minus AP into AC minus RC into AC. Now AC, in place of AC you put AB plus BC. This is half. This is AP plus AB plus QB plus into AB plus BQ into BC plus RC into BC minus AP. In place of AC you write AB plus BC, and this minus is RC AB plus BC. RC AB BC. Now if you take it to be this on this side, so this is nothing equals this is, then AP into AB gets cancelled, which implies I can substitute the AP AB. This is minus sign, and minus APBC. APBC will be left, and from here RC into AB, RC into BC, RC into BC. This is RC into BC gets cancelled. So what you are left with, this is only half. This is QB into AB plus BQ into BC minus AP into BC AP into BC minus RC into AB. And if you see from diagram says, now if you substitute the value, what is RC? RC is, from the figure you can see that this RC is nothing but Y3. This length is Y3. y3. So RC is y3. What is AB? AB is, this length is x2 minus x1. This length, if you calculate it, this is x2 minus x1. And what is BC? This length is x3 minus x2. What is AP? AP, this length is, again this is y1. BQ into BC. What is BQ? BQ length is y2. BC is, yes, we have calculated AB this much. So if you substitute these values, the QB, what is QB? This is the thing, this is half. What is QB? Half. What is QB? Q into B. Q into QB. Length QB is y2. Y2. What is AB? AB is x2 minus x1. Y plus what is BQ minus, then by Q into BC. BQ is QB, BQ is same thing. BQ into BC. BQ is again y2. BC is minus AP. AP is y1. What is BC? x3 minus x1, x2, sorry. BC is x3 minus x2 and minus RC. RC is RC y3 into what is AB? AB is x2 minus x1. You see here this y2 and y2 is common here. Y2 and y2, and if you see, and this is x2 minus x1, x3 minus x2. This x2 and this x2 gets cancelled, so ultimately it becomes half. This is y2 x3 minus x1. If I take plus y1, this inside will change. This is x2 minus x3. If I again take y3 as here, this will inside will become x1 minus x2. So ultimately the formula will, I am writing first y1, this is y1, x2 minus x3 plus then y2 x3 minus x1 plus y3 x1 minus x3, sorry, x2 minus x2. This is your main formula. This is your main formula. This is called area. This is used to calculate the area of triangle. To find it, and how to remember this? You can see this is already remember that 1, then 2, then 3, then again 2, 1. So see, there is, if there is y1, next we need to multiply x. So 1 is gone. Next is x2 minus x3. Minus x3. This is done. Then y2. If this is now y1 is over, then y2. Y2. Next is 3 and then 1. So x3 minus x1. Sorry, this is x3 minus x1. Now next is y3. If y3 is considered, then 1 minus 2. So x1 minus x2. x1 minus x2. So this way you can find the values of area of the triangle formed by the coordinates x1 y1, x2 y2, and x3 y3 is half y1 x2 minus x3 plus plus y2 x2 minus x3 y2 x3 minus x1 plus y3 x1 minus x2. So now question can be framed. You can frame that, suppose this is my 2 comma 3, this is 1 comma 5. Find the distance between these 2 points. How will calculate distance? This is, you know that the distance PQ is nothing but this is x2 minus x1 square plus y2 minus y1 square under root. If I take this coordinate to be x1 y1, this is x2 y2, what this will become? This under root x2 is 1 minus 2 whole square plus one more thing that in the previous is that after this there is a modulus sign, because if this area cannot be negative and I have considered only first quadrant, if the triangle is given to be third quadrant, this values come to be negative, so modulus of whole thing. So in next is just y2 minus y1. What is y2? y2 is 5 minus y1 is 3 whole square. So this is 1 square plus 2 square and the root 5. What is this? Unit square. This is given to be in unit. So if nothing is mentioned, then unit square, because unit, not unit square, unit, because it is a distance. Distance always is a unit in units. Now next is that find the point. This is 1 4 1 4 and this is suppose 1 and 4 and this is minus 1 and 8. Now in what ratio? So this is PQ. In what ratio the point R on y-axis divide this in the ratio? See, it is given that this is on y-axis. So this is on y-axis. What is the coordinate? This, if I take this x to be xy, this is in y-axis, which means on y-axis, any point on y-axis, the x coordinate will be 0. This will be ultimately 0 comma y. Now let me suppose this divides the ratio in k is to 1. Divide it into ratio k is to 1. So how will I write this? Is x equals to, so this is, I take this is x1, this is y1, this is x2, this is y2. See, near to x1 y1 is k, so it will multiply with opposite. This is like this and this is like this. So this is x1 into 1 plus x2 into k by 1 plus k. What is y? Y is y1 1 plus y2 k by 1 plus k. So it will be given in question, it divides PQ. Had it divides QP in case to 1, then this will be k and this will be 1. Always remember this is QP and this is PQ. There's difference between PQ and QP. So this will be, this is x1 is given to be 1, so 1 plus what is x2? x2 is minus 1 and this is minus k, 1 minus k by 1 plus k. Now for x, you all know that this is on y-axis, which implies x is 0. So from here, which implies that the 1 minus k equal to 0, which implies that k equals 1. K equals 1. Now what is y, y is nothing but, now you have calculated that this is y, so which is this divides in ratio 1 is to 1. Now you need to find the value of this coordinates of this point r. So one coordinate, you know, the one value is known, x coordinate you know that this is 0. What is y? So y coordinate can find this is 1, y1. What is y1? y1 is going to be 4, 4 into 1 is 4. What is y2? y2 is 8, 8 into k, y1 plus k. Now it is given that k is 1. I have calculated that k is 1, which means y equal to 4 plus 8. 8 into 1 is 1, and 1 plus 1, this is 2. So this is 12 by 2, this is 6. So this coordinate will be 0, 6. So this point 0, 6 divide PQ in the ratio 1 is to 1, where the point R, this is whose coordinate is 0, 6, lies on y axis. Lies on y axis. Other question will be, prove that this and this, there will be a point, this is x1 y1, this is x2 y2, x3 y3, and x4 y4 forms a parallelogram. Forms a parallelogram. Now this forms a parallelogram. Then if I say take this is to be point P, this is point Q, this is point R, then this is point there. Then you need to calculate PQ, QR, RS, and SP. Now if you calculate all these distance, this opposite and this is taken, well, this is then taken in same order. This is then taken the same order, which implies that PQ, this PQ will be ultimately equal to PS, and this QR will ultimately equal to SP. Because this is taken to be in order, then this can be this P, Q, R, and S. Then this side is equal to this side, and this side is equal to this side. So this can be found to be parallelogram. And had it been a question that it forms a square, this forms a square, which implies that all the sides will be equal. PQ equal to QR equal to RS equal to SP, and the diagonals PR and QS will also be equal. PR and RS will also be equal. One more thing, that this in square, this will be this diagonal intersect at center. The square diagonal intersect at center. We draw this, then this is the center value, and this divides the 1:1 ratio. This will be helpful in solving many questions. Now this I have given them. Now next is find the area of the triangle. So directly triangle, if you are given the 3 coordinates of triangle, then it will be very much easier to find the area. Now had it been given that define the area of the parallelogram, how will we find the area of the parallelogram? So suppose this is the parallelogram only. So first you join this and calculate the area of PSQ. Next you need to find the area of QRS, and then if you add the two, we'll get the area of the parallelogram. So this will be area of the parallelogram. And one more thing, that if suppose it is given the question that prove that the points, suppose P, Q, R, the coordinate will be given that this is x1, y1, x2, y2, and x3, y3 are collinear or are in straight line, then for this, if you join this, theoretically, if you see this, if something is a collinear, 3 points are collinear, then the area made by this is 0. Also, you will apply the formula of a triangle and you will equate the value of 0. And you can check that if area is 0, that means that this 3 points lie on a 3 points lie on a straight line or are collinear. Alternatively, you can do by longer method, that is, you can first calculate PQ, then calculate QR, and then calculate RP. And if you see that this PQ plus QR equal to RP, if this somehow satisfy, then it is prove that this is nothing but they are collinear. They will be collinear because in triangle you always know that the sum of the sides of the triangle. If you add the sum of any two sides of a triangle, is always greater than the third side. And yes, if this is given that this forms a triangle, suppose if any 3 point forms a triangle, if you directly if you find the area of the three area, it should be not non-negative, non-zero, not should not be equal to 0. Alternatively, you can also do this that if you find the distance, this is d1, this is d2, and this is d3. This d1 plus d2 should be greater than d3. When you check, this is d2 plus d3 should be greater than d1, and d3 plus d1 should be greater than d2. So much three things works have to be done to prove that this forms a triangle. Or alternatively, you can apply directly an area of the triangle formula, and you can, if the value is not non-zero, which implies that this forms a triangle. So the basics of the this portion, the coordinate geometry, I think is over. And let me check with the last summary. Summary points are important. Summary, yes, I have shown you half of this formula, half, yes. And x1 minus x2 is formula, distance formula I have given. And yes, one more thing is this is not, though this is not required, but still, if any point, suppose there is a point P, this is here, this is x1, y1, this is x coordinate, y coordinate, and since this is a graph, this is x dash, y, this is y dash. I need to find this distance of this point from origin. Easily you can apply this as 0 is nothing but 0, 0, and if you apply the formula of distance, you will get that this is x1 square plus y1 square under root. This is distance of origin. The point from origin is nothing but this is its square of its both coordinate, epsica and mentissa square under root will give you the distance from origin. And this always remember this is in unit. And area will be given, area of any surface or any thing in coordinate geometry will be given by in unit square. So this will be CORDI NAT coordinate geometry part 1. With this, I have finished my basics of coordinate geometry. So next exercise I will be going with the next lecture. I will go with the exercises. Thank you.